Find the probability that a randomly selected worker has 1 month's income or more set aside. So 1 month's income or more is total of 138. 138 divided by the grand total, that's 287. So 138 divided by 287. So that's 0.4808. 4808. Nearest 1000 means 0.481. Given that a randomly selected worker is male, find the probability that the worker has less than 1 month's income. So this time they've changed the order of the sentence. Usually this given part is the second half of the sentence, but they can place it anywhere they like. So the key thing is that you just look at where the given is, and whatever is given, that's your grand total. So we're given that a randomly selected worker is male. So the males are the whole world in this problem. So it's just this 142 men, and we won't even look at the women in this problem. So what do we want? Find the probability that a worker has less than 1 month's income. So less than 1 month's income is 66, and the total men are 142. 66 divided by 142. 0.465. Given that a randomly selected worker has less than 1 month's income or more, so now less than 1 month's income, a randomly selected worker has 1 month's income or more. So now 1 month's income or more is given, so that's your whole world, 1 month's income or more. So the second row is the only row you look at. Find the probability that the worker is female. So in the second row, we have 62 females, and the total is 138. So 62 divided by 138. And let's do it. 62 divided by 138. 0.449. Not a comma. Okay, are the events having less than 1 month's income saved and being male independent or dependent? So now for this one, we recall that so less than 1 month's income and male. So L and M are independent if probability L and M equals PL PM. And that's what we studied in the previous section, that for independent events, the probability of one and the other gets multiplied. Okay, so we have the data to get all these numbers, and we will check to see if this L and M comes out to be equal to L and PL times PM. So L and M. L and M, L and M would be L is less and M is 66. So that's 66 and the total is 287. So 66 by 287 is the left one. And the question is this equal to PL times PM? So PL is just the less income. So the less income will be 149. Less is this one, 149 over 287. 149 over 287. And the PM is the male. So the male is 142 out of 287. 142 out of 287. Okay, so I calculate the right hand side. 149 over 287 times 142 over 287. 149 times 142 divided by 287 squared. So the right side comes out to be 0.2568 and the left side is just 66 by 287. So 66 by 287, that's 0.229. So they are not the same. The 0.256 is not the same as 229. So they're quite close, but if they are different, if PA and B is different from PA, PB, then they are not independent. So not independent means that they are dependent. Suppose 13.7% probability that a randomly selected person, 35-year-old, is a jogger. 29.5% probability that randomly selected person, a 35-year-old, is a male, given that he or she jogs. So male given jogs. So male given jogs is equal to 29.5%, so 0.295. Okay. What's the probability a 35 or older is a male and jogs? So it's the problem where usually we have to find this given part, but this time the given part is given to us. The male given jogs is 0.295. So let's look at the formula. So it's like male given jogs. So the formula will be male and jogs divided by jogs. So male given jogs is given to us. It's given that 0.295. 0.295 is equal to male and jogs has to be calculated. So let's say X divided by jogs. Jogs must be given to us. Right. There's a 13.7% probability that a person is a jogger. So 0.137. 0.137. So this is an algebra equation. To get x out of here, you multiply both sides by 0.137. So 0.295 times 0.137 is equal to x. So let's say 0.295 and 0.137. 0.295 into 0.137 is 0.0404. 0.0404. Oh, 3 decimal places, so 0.040. Okay. Would it be unusual? Well, 0.04 is 4%, so that is less than 5%. So anything less than 5% is unusual, yes. And that's the end of the section.